This is 5.3, sum and difference properties. Okay, we're going to start by talking about even and odd functions. In order to be an even function, let's see, if you look at an even function, the way I would say this is no matter what you plug in, if you plug in a positive or a negative x value, your answer should be the same, whether it's positive or negative. Now I'm going to draw a graph to show this. Let's see, let's sketch a cosine graph. So cosine starts up here at the top and goes like this. And I'm going to sketch the other side as well. And I'm going to plug in some points to make it even more specific. So this is 0. This is going to be 90. This is 180. And this is 270. Just so y'all can tell me or see exactly what I'm talking about. So of course this is 0. This is going to be negative 90, negative 180. Oops, I don't know why I put that there. And this is negative 270. Okay, so this is the cosine. Okay, if I were to plug in, let's plug in a little bit more here. If I were to give you a positive 180, a positive 180 gives you a negative value, but a negative 180 also gives you a negative value. So if I plug in a positive and a negative, I get the same negative answer. That's what I mean, same. Okay, if I plug in, let's plug in here, a 45 or a half here. If I plug in a positive 45, I get a positive value. If I plug in a negative 45, I get a positive value. So no matter what, if I plug in a positive or a negative, I'm getting the same answer. I'm getting the positive answer, or I'm getting a negative answer. That's what I mean by that. Okay, so I can jump down here as I'm telling you, cosine is going to be an even function. Okay, let's look at something different here. I don't know if this is going to show up. What if I sketched, since I have this, what if I sketch a secant graph? So secant comes off of this, comes off of these, and it will come off of here. So what about secant? If I plug in a positive or negative value, would I get the same answer, positive or negative? So let's look. Let's go with the same things that I did for cosine. If I plugged in a positive 45, I get a positive answer. If I plug in a negative 45, I get that same positive answer. Let's do 180 again. I plug in a positive 180, I get a negative 1. I plug in a negative 180, I get that negative 1. So it looks like my, let's go back and label that. This was secant. So it looks like another even function is going to be secant. Okay, let's draw a sine function. So sine starts here and goes up. Ooh, that was really bad. So this is negative 90. This is positive 90. Okay, let's check those. That looks like really easy to check. If I plug in a positive 90, I get a positive 1. If I plug in a negative 90, I get negative 1. So it looks like if I plug in a positive and negative, I do not get the same answer. Therefore, sine is going to be an odd function. Okay, so in this one, if you plug in a positive and negative x value, you do not get the same answer. So that would be better, different answer. So if sine is giving you a different answer, we can only guess, since cosine and secant were the same, I'm going to guess that sine and cosecant are going to be the same here. So the only thing we need to check out is tangent. So I'm going to draw a quick tangent graph. Let's see, tangent goes through the middle. That's going to be an asymptote. Okay, so let's look at tangent. I'm just going to pick a point here. If I pick this point, if this is the positive and a negative, then this positive value is going to give you a positive answer, and this negative is going to give you a negative answer. So this is going to be an odd function. So this is tangent. And if tangent is an odd function, then that means that cotangent is also an odd function. Okay, so the only evens are cosine and secant. Okay, let's look at some cofunction. So what does co mean? So cofunction stands for a complement. Okay, and I think of complement as meaning 90 degrees. So the complement of 36, of course, you're just going to say 90 minus 36, and that would be 54 degrees. So the cosine of an angle equals the sine of its angle's complement. Okay, so they said the cosine of an angle equals the sine. So they're throwing cosine and sine together. So for example, sine of 36 is equal to cosine of 54. Meaning if I want the complement of sine of 20 degrees, then I'm going to say cosine of 90 minus 20 degrees. Therefore, my answer would be cosine of 70 degrees. Okay? So right now, I know some cofunctions. The cofunction of cosine is sine. It says, what is the cofunction of tangent? Well, the cofunction of tangent is cotangent. So I'm going to write that over here. Tangent's cofunction is cotangent. Therefore, the last one is, what's the cofunction of secant? And it has to be cosecant. So secant's cofunction is cosecant. So use cofunction properties to write the equivalent trig function. Okay, so we need to know the cofunctions here. And cofunctions just means you're working with 90 degrees. So cofunction of cosecant, that means I immediately go to secant, and I'm going to do 90 minus 35, which gives me a secant of 55 degrees. A tangent of 15 degrees. So tangent, our cofunction is cotangent, so I'm going to say cotangent of 90 minus 15. So my cotangent would be cotangent of 75 degrees. Okay, this one's not on there. I'm going to do one more example. How about we do sine of 3 pi over 4. Automatically, you're going to go to cosine, and you're going to do 90 minus. So 90 is pi over 2 minus 3 pi over 4. You're going to have to find a common denominator. Your answer is going to be cosine of negative pi over 4. Just to throw our radians at you. Okay, so a sum and difference, which is a composite argument. Okay, so this is what the title of this whole worksheet is about. So now I want you to pull out your properties, and you picked that up in class yesterday or today. And I want you to look at your sum and difference properties. It's at the bottom of the worksheet. It says composite argument. And it says show that cosine of a plus b does not equal this. Okay, so we're going to kind of have to do a small proof. Okay, on the bottom, I want you to look for cosine of a plus b. It's on the left side of the worksheet or on your formula chart. I'm going to prove that this is not equal to. We know that a is 30 degrees and b is 90 degrees. So I'm going to show that by filling this in, that cosine of 30 degrees plus 90 degrees. And I can show what these values are. So let's see. This is going to be 120 degrees. How about we graph this? Cosine of 120 is going to fall in the third quadrant. Okay, that's 120. So that means that this is 60 degrees. By filling in my ratios, I know this is root 3, this is 2, and this is 1. And it looks like that might be a negative 1 right there. Okay, so cosine of this is going to be equal to negative 1/2. You can also check this by all students, so I know cosine is going to be negative right there. Okay, now I'm going to go over here and do the right side of my problem. So cosine of A plus cosine of B. Cosine of A is going to be 30 degrees plus cosine of B, which is 90 degrees. So cosine of A, again, I'm drawing my triangles. So cosine of A is right here. That's 30 degrees. That's 2, that's 1, and that's root 3. So that is going to be root 3 over 2. Cosine of 90 degrees, looks like I'm going to have to do my chart, and I'm going to draw that out really quick. For those of you who have forgotten, this is 0 degrees and 90. That's where it starts. So cosine of 90 is going to be a 0. So root 3 over 2 plus 0 is going to give you root 3 over 2. So I just proved that these were not equal because the left side is negative 1/2. The right side is root 3 over 2. Therefore, this is not equal to. Okay, number 4 says simplify the given expression using some and different properties. Okay, so again, I'm looking at the bottom of your worksheet, and it says simplify it. So I'm looking for a property that shows cosine times cosine plus sine times sine. And it looks like should be like an A and a B. Again, this is an A and a B. Okay, so it looks like we can simplify this down to a cosine of an A minus B formula. So this is cosine of 20 minus, oh, that should not be right. I think this is a mistake. I think this should be a 34 and a 20, so I'm going to change this. This should be 34 and this should be 20. I think that is a total mistake there. So sorry. This is your 34. This is your 20. This is your 34 and this is your 20. Can y'all fix that? Okay. And therefore, this should be 34 minus, whoops. Therefore, this is 34 minus 20 degrees. And when you simplify that, that gives you cosine of 14 degrees. And then that's your final answer. Sorry about that, guys. Okay, on example 5. Still using those properties on the bottom, it says cosine of x minus pi. I'm going to prove this. So again, you can pick either side. I'm going to pick the left side because it's more complicated. But again, I'm still using those composite arguments on the bottom of the page. So this is an A minus B format. So it looks like the formula is going to be cosine of x times cosine of pi plus sine of x times sine of pi. Okay, I can do nothing with this cosine of x, but I can find the value of this by looking at the chart. So I'm going to pull that out to the side and find the value of that on my chart. So the value of cosine of pi, which is 180, is going to be a negative 1. I can't do anything with sine of x, but I can find the value of sine of 180, and that is 0. So sine times 0, that's going to cancel. And cosine times negative 1 gives me negative cosine of x. And I'm done with that proof. Okay, this bottom one, it says prove this value. Okay, this one is a little bit different because I don't have anything that says cosecant. But I do know cosecant is 1 over. So I forgot by writing my original. So sorry. So cosecant of theta minus 90 is my original. And how about we fix that by changing that to 1 over sine. And then we do have properties that have sine in them. That's going to make that a little bit easier. Okay, by using a sine property now, I can say sine of theta times cosine of 90 degrees minus cosine of theta times sine of 90 degrees. Okay, let's simplify this. I can't do anything with sine of theta. Cosine of 90 degrees is a 0. Cosine of theta I can bring down. Sine of 90 is 1. So again, that is out. So it looks like we've got it over a negative cosine of theta. And I know that 1 over cosine is secant. And I think that's what we were looking for in solving this problem, so we are done. Okay, if you've got questions, please ask in class.